Alright, hey guys, so I know it's been a while and look at this, I'm just all alone in here. There's nobody in here, not a single soul. Look at my sweet cornhole boards, you can't really see them in the corner there, but they're legit. So I thought I'd make this video to help you guys figure out confidence intervals. So, here's the scenario. Kobe Bryant had 2 games in his regular season and he took 45 shots and he only made 17, which yikes, not that good. So what we're going to do is try and find the confidence interval based on this. Now, what we need to know is everything we do is to find the ability. But what we know is a performance. We know the performance of Kobe. So in those 2 games, his performance, or we call that our good friend P hat, okay, was 17 out of 45. Okay, so 17 out of 45. I'm bugged that it shows that eraser. Okay, I'm over it. Or 0.378 if we divide. It's like 3.777, so we're going to round up. So our best guess is that it's based on this performance, which we know, best case scenario, we have more data, but we're going to take what we can get right now. So what we need to do is with that, we're going to do a confidence interval because we don't actually think that 0.378 is accurate. We want to find a range of numbers that is going to maybe get us more accurate, specifically 95% accurate. So we want to be 95% confident. Now, let me show you where this comes from. So remember our good old friend, the bell curve. Woohoo, here it is. So here's our center, and remember the 68, 95, 99.7 rule. So remember with 68, that meant 68% of our data should be within 1 standard deviation. Then the 95%, which is what we care about, should be within 2. So most of our data, 95% of it, should be within 2 standard deviations of the center. So that's what we're going to bank off of here. That's why we want to be 95% confident, is kind of based on this. Okay, so you should have this fancy schmancy equation that says we're going to take p hat. So our performance that we have is going to be our center. And we want to find 2. So that's our 2 from within 2 standard deviations. And essentially this is how we find the standard deviation. We take p hat and then we do 1 minus p hat all divided by n. Okay? So p hat is our 0.378. So what actually happened? So 0.378 plus or minus 2 times, we know our p hat, 0.378. So remember that's his performance. So now we want to times by the percentage that he missed. So we can find that by doing 1 minus 0.378, which gets us 0.622. Okay, and then we're going to divide by n. Now remember, n is our number of observations or trials. And he made 17, but he shot 45. So this is out of 45. So then we can just do some plugging and chugging here. 0.378 times 0.622. We're going to find out what that is and divide it by how many we have. And then we got to take the square root. Okay, so this gets us 0.378 plus or minus 2 times 0.072. Okay? So, I'm actually gonna, let's do this. Okay, so, this is what we got then. If we times this by 2, times this out, we got 0.378 plus or minus 0.144. So essentially, we've got this. Here's our center, 0.378. Here's our curve. We think within 2 standard deviations, which is this number, 0.144, is going to be where most of our data is. Or our 95% confidence is going to be there. Okay, so we're going to add 0.378 plus 0.144. And that gives us 0.522. Matt, you better check because the chances that I'm wrong are pretty high these days. Okay? And then we're going to subtract that to get the 2 standard deviations below the center, below the performance, 0.234. Okay? So essentially we're saying we are 95% confident that his ability is from somewhere in between 0.234 and 0.522. So We write that by putting in the brackets point, not what I wanted, 0.234 to 0.522. And we can say we are 95% confident that Kobe's ability is somewhere in between 0.234 and 0.522. Okay?